In our third example of a quadratic application, we're dealing with a penny drop. If a penny is dropped from a bridge at Royal Gorge, Colorado, the event can be modeled with the function h of t equals negative 16t squared plus 1,000. The first question asks, what is the height of the penny after 3 seconds? Seconds deals with time, so we're going to substitute 3 for time into our given function. So our evaluation would be the height is evaluated at the time 3 seconds. Using our order of operations, we would square 3 first, and that means negative 16 is now multiplied by 9, and then we'll add 1,000. So the height after 3 seconds is going to be 856 feet. We've generated our first ordered pair. With time, we were given 3 seconds, and height turned out to be 856. For the second question, we'll determine the vertex point. For vertex point, x is equal to minus b divided by 2a. So we'll need to find the values of a and b back in the original function. Notice we have our second degree term, so that coefficient of negative 16 tells us the value of a, but 1,000 is the constant. That's the c value. We don't have any term here that's a first degree. Therefore, b must be 0. So that would be negative times 0 divided by 2 times negative 16. So 0 is divided by negative 32. Keep going to simplify that. It really is 0. So the x value for our vertex point is 0. That means we need to evaluate the function using an x value of 0 now. Height at time 0 would equal negative 16 times the quantity of 0 squared plus 1,000. 0 squared is 0, times negative 16 is 0. That leaves us 1,000 for the output. So when the time is 0, the output is 1,000. That also happens to be our y-intercept. For question 3, how long does it take the penny to reach the Arkansas River, which is 1,000 feet below? Notice that number 1,000 was also in the original function, and that simply told us, in a sense, that is the ground. So we're really looking for how much time does it take for this penny to hit the ground, which is the river. So our height is 0. To solve this quadratic equation, notice there are only 2 terms, so we should add 16t squared to each side, and we'll be able to use our square root property to solve it. 16t squared now equals 1,000. We'll just need to undo the squaring of t and the multiplication of 16. So if we start by dividing each side by 16, we'll end up with t squared equals the fraction 1,000 divided by 16. So don't worry about reducing the fraction, because our next step would be to take the square root of each side of this equation. So the square root of t squared is now equal to plus or minus the square root of this fraction. Do we need to consider both of the roots? A positive number or a positive root, that makes sense because time would have to be positive. But if we use the negative, that would be negative seconds. So we really don't need to use plus minus. Just the positive root would make sense here. Using our calculator, I'll take 1,000 and divide that by 16, and then use the square root function to get a decimal approximation. So time is going to be about 7.9 seconds. Again, only positive 7.9 seconds would make any sense. So t value of 7.9, that's the input. Height was 0 for the output. That's our x-intercept. So we have enough information now to plot these ordered pairs to see what this quadratic function looks like. For time, Again, only positive numbers or zeros would make sense. Height is the same situation. 0 and positive numbers are the only ones that would make sense. So we can use the edges of our graph for time in seconds. And height would be along this other edge because only the positive numbers would make sense. And this is height in feet. Our scale would start with 0. The most amount of time involved here is our largest number, 7.9 seconds. So just to spread this out a little bit, I'm going to skip every other line and just count by ones. Our largest height is 1,000 feet. So if I counted by 50s, that means every 2 lines is worth 100. So make sure you're consistent with counting by 50s. 50, 100, 150, 200, and so on. Now we're ready to plot our ordered pairs. I'm going to start with the intercepts. Those would be the quickest. 0, 1,000 is the y-intercept. And then 7.90 is our x-intercept. So 7.9 is almost to 8 seconds. Now if that's all we plot, that's going to be a straight line, and we know this is not a straight line because we have a quadratic term. So it's very important to plot at least one more point on the function. 3,856 should help us to see a gentle curve occurring. So let's connect our ordered pairs to see what this parabola looks like. Now that we have the ordered pairs connected, notice this is only part of our parabola. It's not the complete parabola because anything going on the left side would be negative time. So we're really only looking at a portion, and that's where domain and range come in. For question 4, our domain deals with time. So only from 0 to 7.9 seconds make any sense. Smallest to largest. The range deals with height. Our lowest height is when the penny is sitting right on the river, which represents the ground. That would be 0. And it's dropped from a height of 1,000, so it's never going to be higher than 1,000 feet. So that's our largest value for the range. So I hope you found this video helpful.